welcome again. We have discussed the continuity of function at a given point in our previous two videos. In those videos, we have discussed the continuity of function when we have f of x equals to phi of x when x is not equal to a, and f of x equals to psi of x when x equals to a. And in the second video, we have discussed the continuity of a function when the function is of the form f of x equals to phi of x when x is less than equal to a, and psi of x when x is greater than a, or f of x is equal to phi of x when x is less than a, and psi of x when x is greater than or equal to a. In those videos, we have discussed that how to find the left hand limit and right hand limit in all these cases. And we have proved that the function is continuous at a given point a if the left hand limit at a is equal to right hand limit at a and is equal to image at a. Now, in this video, we are going to discuss about the continuity of the composite functions. But before we shall start with the continuity of the composite functions, let's discuss few questions. That is, first one is discuss the continuity of sine function. That is, this time we're given that f of x is equal to sine of x. And in our class 11th, we have seen that the graph of sine function is a sort of wave having the maximum value 1 and the minimum value -1. And you can easily observe that this function is without a break or a jump or a hole. Now, the maximum value of this function was 1 and the minimum value is -1. In the same class, we have defined that the domain of this function was set of real numbers and range of this function was -1 to 1, where -1 and 1 are included. Now, in this question, we are going to prove that mathematically this function is a continuous function. Since real numbers are infinite and it is not possible for us to prove that this function is continuous for every real number. So, we are assuming that C is a real number and we should prove the continuity of this function at C. So, for proving a continuity at C, we need to prove that the left hand limit at C is equal to right hand limit at C is equal to image at C. Now, first, left hand limit at C, that is x approaches to C from those numbers which are less than C of f of x. हम लेफ्ट हैंड लिमिट को कैलकुलेट कर रहे हैं. लेफ्ट हैंड लिमिट के लिए हम अप्रोच कर रहे हैं सी को उन नंबरों से जो सी से छोटे हैं. तो ये किसके इक्वल हो जाएगा? h approaches to 0 f of c minus h, which equals to limit h goes to 0 of sin of c minus h, क्योंकि f of x हमारा sin of x के इक्वल है. ये इंडिटरमिनेट फॉर्म में नहीं है. जब हम h को 0 पुट करते हैं तो डायरेक्टली हम h की वैल्यू 0 इसमें सब्स्टिट्यूट करेंगे, जिससे हमारे पास लेफ्ट हैंड लिमिट किसके इक्वल आ जाएगा? साइन ऑफ c के इक्वल. इसी तरह से हम इसका राइट हैंड लिमिट कैलकुलेट करेंगे. x अप्रोचेस टू c प्लस ऑफ f of x, जो कि इक्वल हो जाएगा लिमिट h goes to 0 f of c plus h, which equals to limit h goes to 0 of sine of c plus h, which equals to sine of c plus 0, or sine c plus 0 is equal to sine of c. Also, f of c is equal to sine of c. तो हम इन तीनों टर्म्स को देखें तो ये सेम है. तो यहाँ से हम कंक्लूड कर सकते हैं that is limit x approaches to c negative of f of x is equal to limit x approaches to c plus of f of x is equal to f of c. Means left hand limit at c is equal to right hand limit at c is equal to image at c. This means f is continuous at x equals to c. जो c हमने चूज किया था that was arbitrary number, since since C belongs to set of real numbers is an arbitrary number. Hence, f of x equals to sine of x is continuous for all x belongs to real numbers. अब यहाँ पर हमारे पास रियल नंबर्स इनफाइनाइट थे, तो इसलिए हमने आर्बिट्रेरली कोई भी एक रियल नंबर सी अज्यूम किया, उस पे पता है कि लेफ्ट हैंड लिमिट इज इक्वल टू राइट हैंड लिमिट इज इक्वल टू इमेज, और वहां से कंक्लूड कर दिया कि जो गिवन फंक्शन साइन ऑफ एक्स है दैट इज कंटिन्यूअस फॉर ऑल द रियल नंबर्स। चलिए आगे बढ़ते हैं, दूसरा एग्जांपल। प्रूव दैट f of x equals to e raised to power x is continuous function in its domain। इस बार जो हमें फंक्शन दिया हो एफ ऑफ एक्स इक्वल्स टू ई रेज टू पावर एक्स, जिसको आप एक्सपोनेंशियल फंक्शन बोलते हो। क्लास 11th में लिमिट्स एंड डेरिवेटिव्स में इसको डिफाइन किया था, और वहां पर आपने इसका ग्राफ भी देखा था। मैं ग्राफ यहाँ पर रिप्रेजेंट कर रहा हूँ। जब x का वैल्यू 0 होगा तो e रेज टू पावर 0 इज 1, और जब x 0 से छोटा होगा then it will be tending towards, sorry, when x is less than 0 then its graph is between 0 and 1, और जैसे x का वैल्यू 0 से बढ़ता है तो it will increase, and you can observe that I can plot this graph without lifting the pen, so that means it is a continuous function, और हमें प्रूव करना है कि ये continuous है मैथमेटिकली। अगर आप इसकी डोमेन की बात करें क्लास 11th में, तो आपने वहां पर डिफाइन किया था कि दिस फंक्शन इज डिफाइंड फॉर ऑल रियल नंबर्स, और इसका रेंज जो है आप ग्राफ से भी देख सकते हो, इट इज नेवर एवर 0, सो इसका रेंज जो है 0 टू इंफिनिटी, दैट इज सेट ऑफ पॉजिटिव रियल नंबर्स। अब मेरे को प्रूव यहाँ पर इस क्वेश्चन को प्रूव करना है कि फंक्शन कंटिन्यूस है मैथमेटिकली, तो फिर से मैं अज्यूम करता हूँ कि सी मेरे पास कोई भी एक रियल नंबर है। मैं प्रूव करूंगा कि ये फंक्शन जो है सी पर कंटिन्यूस है। तो अगर किसी भी फंक्शन को किसी पॉइंट पे कंटिन्यूस बताना है तो आपको बताना है कि उसका लेफ्ट हैंड लिमिट, राइट हैंड लिमिट और इमेज जो है इक्वल है। तो यहाँ पर हम पहले कैलकुलेट कर रहे हैं इसका लेफ्ट हैंड लिमिट एट सी, जिसको हम डिनोट करते हैं लिमिट x approaches to c negative of f of x, which equals to limit h goes to 0 f of c minus h, which is equal to limit h goes to 0 of e raised to power c minus h। क्यों? क्योंकि f of x is e raised to power x, x की जगह पर मैंने c minus h लिखा, तो ये किसके इक्वल हो जाएगा? e raised to power c minus 0 which equals to e raised to power c। Right hand limit at c, again limit h goes to 0 of f of c plus h, which is equal to limit h goes to 0 of e raised to power c plus h. Since it is not attaining the indeterminate form, so we can replace h by 0, so this will be equal to e raised to power c plus 0 which equals to e raised to power c. Now image at c, is equal to e raised to power c. Left hand limit, right hand limit, or image, they are equal, since limit x approaches to c negative of f of x is equal to limit x approaches to c plus of f of x is equal to f of c. This means f is continuous at x equals to c. Again, c जो हमने choose किया था, that was arbitrary, since c belongs to R is arbitrary. Hence, f of x equals to e raised to power x is continuous for every x belongs to domain of exponential function, and domain of exponential function is set of real numbers. Let's take one more example. Prove that f of x is equal to tan of x is continuous in its domain. Again, if you remember the graph of tan function, the graph of tan function was at 0 it is 0, and between 0 to pi by 2 it increases up to infinity, and between 0 to minus pi by 2 to 0 it decreases. It tending towards minus infinity. Now again, between pi by 2 and pi it is tending towards minus infinity, and between pi and 3 pi by 2 it is tending towards positive infinity, and so on. You can plot its various branches. At pi by 2 it is not defined. So from this graph, or from the concept of class 11, if you remember, the domain of tan function was set of all real numbers except those x are, instead of x I'm using all real numbers except 2n plus 1 into pi by 2, where n belongs to set of integers. That means रियल नंबर्स में से हम सभी ऑड मल्टीपल ऑफ 90 को सब्ट्रैक्ट करते हैं तो हमारे पास फंक्शन का डोमेन आ जाता है, और उसका रेंज जो था दैट वाज माइनस इन्फिनिटी टू इन्फिनिटी. नाउ वीडियो 1 में जब हम टाइप 1 डिस्कस कर रहे थे तो वहां पर मैंने आपको एल्जेब्रा ऑफ कंटीन्यूअस फंक्शन बताया था, और वहां पर मैंने आपको बताया था कि जब भी हमारे पास दो कंटीन्यूअस फंक्शंस होते हैं, जब भी हमारे पास दो कंटीन्यूअस फंक्शंस होते हैं, सपोज एफ और जी आर कंटीन्यूअस at x equals to a, then f plus g is continuous at x equals to a, f minus g is continuous at x equals to a, f into g is continuous at x equals to a, and f upon g is continuous at a if g of a is not equal to 0. So we are going to use this concept to prove this function. चलिए, तो f of x this time is equal to tan of x, and we know that tan x is equal to sin x upon cos of x. Earlier we have proved that sine function is a continuous function, and similarly we can prove that cosine function is also continuous for every x belongs to R, or quotient of two continuous functions is a continuous function, since sine of x is continuous for every x belongs to R, and cos of x is continuous for every x belongs to R. Therefore, therefore, sin x upon cos of x is continuous for every x belongs to R, and and cos of x is not equal to 0. Instead of n, when cos of x is not equal to 0, and cos of x is equal to 0 at all odd multiples of 90. So this quotient is continuous. This quotient is continuous. That is sin of x upon cos of x is continuous for every x belongs to real numbers except odd multiples of 90. So this is nothing but the domain of tangent function, which we have already defined. Hence, hence, f of x equals to tan of x is continuous for every x belongs to R minus 2n plus 1 into pi by 2, where n is a integer. Again, have a look at the solution of this question. F of x is tan of x. Tan of x का domain जो होता है, that is real numbers except the odd multiples of 90, and range is minus infinity to infinity. That is, f of x is equal to tan of x, that can be put as sin x by cos of x. As we have already seen that sine function is a continuous function for every x belongs to real numbers. Similarly, it can be proved that cosine function is also a continuous function for every x belongs to real numbers. Sine function is continuous, cos function is continuous, so is their quotient provided denominator is not equal to 0. And we know that cos of x is 0. Cos of x is 0 when cos of x is 0 when cos of x is 0 when x is a odd multiple of 90. So that means this function will be continuous if x belongs to all real numbers except 2n plus 1 into pi by 2, where n is an integer. But sin x upon cos x is tan of x. So this will be continuous for every x belongs to R minus 2n plus 1 into pi by 2, where n is an integer. So from this discussion, we are going to conclude certain things. As we have proved that sine function is continuous, exponential function is continuous, tan function is continuous. In the similar fashion, we can prove that all inverse trigonometric functions are continuous in their respective domains. Logarithmic function is continuous in its domain. Then algebraic means polynomial functions are continuous in all the whole of R. Trigonometric functions are continuous in their respective domains. Exponential function, we have already proved that it is a continuous function. So, to remember all those things, I'm putting highlight, where I stands for inverse trigonometric functions. L stands for logarithmic function. Here A is algebraic function. T is trigonometric functions. And E is exponential function. And my conclusion is these functions are continuous in their respective domains. That means, for an instance, if I take f of x is equal to sine inverse of x, and we know that domain of this function is -1 to 1. So this function will be continuous for all these numbers which are between -1 and 1, including -1 and 1. Similarly, if we take the case of f of x equals to cot of x, we must have the domain of this function. And as we know that domain of this function is all real numbers except n pi, where n is an integer. So this function will be continuous for all those numbers which belongs to this set. Similarly, if we take f of x is equal to log of x, we must have the domain of this log function, and the domain of log function is set of all positive real numbers. So that means for all positive real numbers, logarithmic function is a continuous function. So that is what I am concluding here. If we have these functions, highlight function, inverse trigonometric functions, your then logarithmic function, then your algebraic function, then trigonometric functions, exponential function. These are continuous function in their respective domains, and you will come across this word again and again in your class 12th. So this is the first chapter where I'm touching this point. Then second thing, earlier we have discussed the algebra of continuity at a point. Now I'm generalizing that thing. Let f and g are two continuous functions. Then first thing, f plus g is continuous. वहां पर हमने डिस्कस किया था एट ए पॉइंट, यहाँ पर हम दो जनरल फंक्शन ले रहे हैं और जनरल कंटिन्यूटी की डिस्कस कर रहे हैं. अगर if हमारे पास कोई फंक्शन है तो it will have a domain. G is a function, then it will have a domain. Then if f and g are two continuous function, then their sum is continuous in domain of f intersection domain of g. इसके लिए थोड़ा सा एक एग्जांपल मैं कोट कर रहा हूँ. सपोज आपके पास f of x जो है that is equal to log of x, और g of x आपके पास है से sin of x. Then f plus g at x is equal to log of x plus sin of x. जैसा कि अभी थोड़ी देर पहले मैंने आपको बोला था, log फंक्शन की डोमेन 0 to infinity होती है और साइन फंक्शन की डोमेन रियल नंबर्स होती है. दैट मीन्स लॉग फंक्शन नेगेटिव नंबर्स के लिए डिफाइन नहीं होता. फंक्शन नेगेटिव और पॉजिटिव वैल्यू सभी के लिए डिफाइंड है. तो जब हम इन दोनों का सम लेके चल रहे हैं तो दिस विल बी डिफाइंड ओनली फॉर the common values, that means those values which are between 0 and infinity. So this function will be continuous for 0 to infinity, which is nothing but the intersection of these two, because 0 to infinity is a subset of real numbers. So that is what we are discussing. If we have f and g as two continuous functions, then their sum is continuous in the common domain of f and g. Similarly, f minus g is continuous in domain of f intersection domain of g. Third, f into g is continuous in domain of f intersection domain of g. Then fourth one, f upon g is continuous in domain of f intersection domain of g minus all those x for gx is equal to 0. That means since it is a rational function, so we cannot allow denominator as 0. So after that, we are starting with the type 3, that is the composite functions. So continuity of composite functions. The concept which we have discussed here, this is very useful in the third type. So before we shall discuss the examples based on this one, let us consider a theorem. Let f and g are real valued functions such that composition of G with F is defined, and G is continuous at x equals to A, and F is continuous at G of A. Then composition of G with F is continuous at x equals to A. क्या मतलब हुआ? अगर F और G, I'm writing again, composite continuity of composite functions. Uh, let's consider theorem based on this one. Let F be a F and G. We are discussing the continuity of composite functions. Let F and G are two real valued functions such that composition of G with F is defined. If G is continuous at x equals to A and F is continuous at G of A, then composition of G with F is continuous at x equals to A. मतलब अगर f और g यहाँ पर दो रियल वैल्यूड फंक्शन है सच दैट हम f की g की कंपोजिशन f के साथ डिफाइन कर सकते हैं और f की कंपोजिशन g के साथ तभी डिफाइन कर सकते हैं whenever the domain of f is superset of range of g या domain of range of g is subset of domain of f. G is continuous at point A or f is continuous at g of a. The fog is continuous at x equals to a. Let's prove this one. We are given that composition of G with F is defined और G की composition F के साथ तभी define हो सकती है जब range of G is subset of domain of F, which implies for every Gx belongs to domain of F, Gx belongs to domain of F for every x belongs to domain of G. अब थोड़ा सा चैप्टर 1 रिलेशंस एंड फंक्शंस पे जाएंगे तो ये मेरे पास suppose set A, this is set B, and this one is set C. G is a function. G is a function from A to B, and F is a function from B to C. Then their composition was represented by F O G, and it is a function from set A to set C. और G का जो range होगा, G का जो range होगा, that will be the subset of domain of F. अगर वो उसका सबसेट नहीं होगा तो तब हम इनको कंपोज नहीं कर पाते. तो यही चीज मैंने यहाँ पर लिखी. For every x belongs to domain of G, there exists Gx belongs to domain of F. Now you are given that G is continuous at x equals to A. Therefore, limit x approaches to A of G of x is equal to G of A, which is the basic definition of continuity. एक फंक्शन जो होता है किसी पॉइंट पे कंटिन्यूस तभी होता है जब limit उस limit of that function exists at that point and it is a finite number, and that limit is equal to the image at that number at that point. Also, we were given that f is continuous at g of a. F is continuous at g of a. Therefore, therefore, limit gx approaches to g of a of f of gx is equal to f of g of a. अगर ये फंक्शन जी ए पे कंटिन्यूस है तो लिमिट जी एक्स, क्योंकि डोमेन ऑफ एफ विल कंटेन ऑल जी एक्स that I have already given. Gx is approaching to g of a of f of gx is equal to image of f at ga. Now limit x approaches to a of f of g of x is equal to f of g of a. इस पॉइंट को अंडरस्टैंड कीजिएगा. when x approaches to a when x approaches to a, this implies gx approaches to g of a. This is from, I will mention that expression as first. So what we are getting, the limiting value of f gx is equal to image at gx. This means limit x approaches to a of f composition g at x is equal to f composition g at a. Hence, FOG is continuous at x equals to a. In short, अगर दो फंक्शन कंटिन्यूस है उनका कंपोजिशन भी कंटिन्यूस होता है. चलिए कुछ एग्जांपल्स करेंगे इस प्रॉपर्टी के ऊपर बेस्ड. Show that f of x is equal to modulus of sin of x plus cos of x is continuous at x equals to. Let's prove this one. We are given that f of x is equal to modulus of sin x plus cos of x. What I'm doing here, I'm letting another function x is equal to mod of x and gx is equal to sin x plus cos x. Now, what about the composition of h and g at x? This will be equal to h of gx. which is equal to h of sin x plus cos x, which equals to sin of x plus cos of x का mod value, which is nothing but f of x. Clear? अगेन देखिए, मैंने एच एक्स को अज्यूम किया मॉडुलस ऑफ एक्स, जी एक्स को मैंने लिया साइन एक्स प्लस कॉस एक्स, तो एच कंपोजिशन जी एट एक्स किसके इक्वल हो गया, एच ऑफ जी ऑफ एक्स, जी एक्स हमारा साइन एक्स प्लस कॉस एक्स के इक्वल है, तो एच ऑफ साइन एक्स प्लस कॉस एक्स विल बी इक्वल टू एच ऑफ साइन एक्स प्लस कॉस एक्स विल बी इक्वल टू मॉडुलस ऑफ साइन एक्स प्लस कॉस एक्स, बिकॉज एच एक्स इज मॉडुलस ऑफ एक्स, और ये फंक्शन जो था हमारा गिवन फंक्शन था. नाउ since modulus function is continuous for every x belongs to R, also sine function and cosine function are continuous for every x belongs to R, which implies, yeah, and we know that sum of two continuous functions is a continuous function. अगर दो फंक्शन कंटिन्यूस है तो उनका सम भी कंटिन्यूस होता है, और अभी रिसेंटली वी हैव प्रूव दैट composition of continuous functions is also composition of continuous functions is a continuous function. So here we are having sum of two continuous function, it will be a continuous function, and composition of two continuous functions is also continuous. Hence f of x equals to modulus of sin x plus cos x is a continuous function. It is continuous for every x belongs to R, hence it is continuous function at x equals to pi. Okay, let's have another example. Suppose this term function is given as directly show that the function defined by f of x equals to cosine of x square is a continuous function. Let's prove this thing. We are given that f of x is equal to cos of x raised to the power 2. I'm assuming that let hx is equal to cos of x and gx is equal to x square. Then h o g at x, that means the composition of g with h will be equal to h of gx, which will be equal to h of x square, and this equals to cos of x square, and this is nothing but the given function. Clearly h and g are continuous for every x belongs to R, and so is their composition. Hence f of x equals to cos of x square is continuous for every x belongs to real numbers. Another example, find all points of discontinuity of f defined by f of x is equal to mod of x plus modulus of x minus 1. Since modulus function is continuous for every x belongs to R. Also, also polynomial functions or algebraic functions are continuous for every x belongs to R. So that means this function is continuous, this internal function is continuous, and we know that composition of two functions is continuous, and composition of two continuous functions is a continuous function. So this implies gx is equal to modulus of x minus 1. Gx equals to modulus of x minus 1 is a continuous function for every x belongs to R. I'm assuming gx is equal to this one, and that hx is equal to modulus of x, which is also continuous for every x belongs to R, and sum of two continuous functions is a continuous function. Hence, 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 f of x, which is equal to hx plus gx, is equal to modulus of x plus modulus of x minus 1 is continuous for every x belongs to R. So whenever we have two composite functions, their composition is continuous. If we have two continuous functions, then their sum is continuous in their common domain. Difference is continuous in their common domain. Product is continuous in their common domain. Quotient is continuous in their common domain, except those points which are making denominator equals to 0. So we are keeping our video up to this point and hope you have understood the concept behind this video and you will try all those questions which are associated with this one. Thank you for this, and we will be meeting again with the concept of differentiability in our next video. Thank you.